Okay? Now, stay with me here. Suppose a new guest shows up at the front desk asking for a room. What will the manager say? No problem, he says. And he moves the guest who was staying in room 1 into room 2. He moves the guest who was in room 2 into room 3. He moves the guest who was in room 3 into room 4, and so on, out to infinity, so that everybody moves into the room number next highest to his own. As a result, room number 1 now becomes vacant, and the new guest is easily accommodated. And yet, before he arrived, all the rooms were already full. Now, if that seems weird, hang on to your hat because it gets even worse. Let's suppose Hilbert says that an infinity of new guests shows up at the front desk asking for rooms. No problem, says the manager. And he moves the guest who was staying in room 1 into room 2. He moves the guest who was in room 2 into room 4. He moves the guest who was in room 3 into room 6, putting each guest into the room number twice his own. 1 into 2, 2 into 4, 3 into 6, 4 into 8, and so on, out to infinity. Now, think about that. Since any number multiplied by 2 is always an even number, all of the guests wind up in the even-numbered rooms, 2, 4, 6, 8, 10, and so forth. As a result, all of the odd-numbered rooms become vacant, and the infinity of new guests gratefully checks in. And yet, before they arrived, all the rooms were already full. In fact, the proprietor could do this an infinite number of times and always be able to accommodate more guests. As one student remarked to me after class, Hilbert's Hotel, if it could exist, would have to have a sign posted outside. No vacancy, guests welcome. Hilbert's Hotel is absurd. Mind you, it's logically correct for the mathematician, but it's impossible for something like Hilbert's Hotel to really exist. You can describe it on paper, but it cannot exist in reality. Illustrations like these show that the existence of an actually infinite number of things is impossible. Now, sometimes people react to Hilbert's Hotel by saying that these paradoxes result because we can't understand the infinite, and it's just beyond us. But this reaction is in fact mistaken and naive. Infinite set theory is a highly developed and well understood branch of modern mathematics. These absurdities result not because we do not understand the infinite, but because we do understand the nature of the actual infinite. Hilbert was a smart guy, and he knew well how to illustrate the bizarre consequences of an actually infinite number of things. Now, what are the implications of all this? Well, if you can't have an actually infinite number of things, then you can't have an actually infinite number of past events. That means that the number of past events in the history of the universe must be finite. But in that case, the past is finite, and therefore the universe began to exist, just as Al-Ghazali claimed. So, I think that Al-Ghazali's argument is a good one. I think that it shows that the number of past events must be finite, and that therefore the universe must have had a beginning. Al-Ghazali had philosophical arguments for the beginning of the universe. But in one of the most startling developments of modern science, which Al-Ghazali could never have anticipated, we now have pretty good scientific evidence that the universe began to exist. The evidence of observational astronomy indicates that the entire universe is expanding, in the sense that the distances between the galaxies grows greater and greater and greater as time goes on. This has the startling implications that as you trace the expansion back in time, the universe gets denser and denser and denser until it finally collapses down to a point before which the universe literally did not exist. And that initial event has come to be known as the Big Bang. What makes the Big Bang so startling is that it represents the origin of the universe from literally nothing. For all matter and energy, even physical space and time themselves, come into being at the moment of the Big Bang. As the British physicist P.C.W. Davies explains, the coming into being of the universe, as discussed in modern science, is not just a matter of imposing some sort of organization upon a previous incoherent state, but literally the coming into being of all physical things from nothing. The standard Big Bang model thus predicts an absolute beginning of the universe. If this model is correct, then we have amazing scientific confirmation of the second premise of Al-Ghazali's cosmological argument. So the question is the standard model correct? Or more accurately, is it correct in predicting an absolute beginning of the universe? Well, although there's a good deal of evidence in favor of the standard Big Bang model, we know that it will need to be modified in certain ways. The standard model is based upon Albert Einstein's general theory of relativity. But Einstein's theory breaks down when the universe is shrunk down to subatomic proportions. At that point, we'll need to introduce subatomic physics in order to describe the universe, and nobody knows how this is to be done. Moreover, the expansion of the universe is probably not constant as it is in the standard model. It's probably accelerating and may have had a brief period of super rapid expansion in the past. But none of these adjustments need affect the fundamental prediction of an absolute beginning to the universe. Ever since the standard model was first proposed back in the 1920s, scientists have proposed scores of alternative models over the decades, and those that do not have an absolute beginning have been repeatedly shown to be unworkable. To put it more positively, the only viable non-standard models are those that involve an absolute beginning to the universe. Now, that beginning may or may not have a beginning point, but on theories like Stephen Hawking's, where the universe does not have a sharply defined point at which it originates, nevertheless, the past is still finite, not infinite. The universe has not existed forever according to such models, but it came into existence even if it didn't do so at a sharply defined point. So, in a sense, the history of 20th century cosmology can be seen as a history of one failed attempt after another to avert the prediction of the beginning of the universe predicted by the standard Big Bang model. Unfortunately, the impression arises as a result in the minds of laymen that the field of cosmology is in constant turnover with no lasting results. What the layperson doesn't appreciate is that this parade of failed theories simply goes to confirm the prediction of the standard model that the universe began to exist. That prediction has now stood for well over 80 years throughout a period of enormous advances in observational astronomy